So today we will continue permutations and combination, basically combinatorics. And today we will learn about grouping and formation of groups, division, distribution, and circular permutation. And if time remains, then we will start also the pigeonhole principle. Only the first principle we will learn today, and in the next day, that is in the third class of combinatorics, we will learn the total two principles of pigeonhole. And basically there are four pigeonhole principles, but the third principle and fourth principle are basically the same. So we will learn three pigeonhole principles in total. So without wasting any more time, we shall start. Okay. Wait. So, okay. So can you see my video?
Yes.
Yeah, it's visible.
Yeah. Okay, please wait. Yeah. So formation of groups. So I should give one example. See, let there are 6 chocolates, and it is to be divided into 3 equal groups. 3 equal groups. Now, dividing 6 among 3 groups equally means each group will get how many chocolates?
2.
2 chocolates. So, 2, 2, 2. So 2 each. Each will get 2 chocolates. Okay. So how many number of possible combinations can be held here? See, first we choose 2 chocolates out of 6 chocolates. So 62 ways. Then we have to choose 2 chocolates again. But now you have to see, out of 6 chocolates, we have already chosen 2 chocolates. So there remains 6 minus 2 equal to 4 chocolates. So the next possible combination is nothing but 4C2. Out of 4 chocolates, we are actually choosing 2 chocolates. Now remaining is 4 chocolates minus 2 chocolates. That is only 2 chocolates. And out of 2 chocolates, we are choosing 2 chocolates. So this. So 2C2. Right? So this is the possible combination. Up to this step, is it clear?
Yes.
So basically what we did, 6C2 into 6 minus 2C2 into 6 minus 2 minus 2C2. So this is basically division among groups. But there is another formula. The chocolate are different. No, till now I didn't told anything. I told chocolates. So this is the general way to do this type of problems. But there are formulas for division, distribution and all. But if you don't know the formula of division, distribution, then you can of course approach like this. But division of 6 chocolates among 3 groups equally. So what should it be done? It should be written as, like you do in normal division, 6 factorial by 2 factorial, 2 factorial, 2 factorial. Right? Right?
Yes.
But there is a trick here. See, yes, in the last class, we learned about identical concept. So in that identical concept, here I told chocolates. So the chocolates may be equal, may not be equal. But since there are the number of chocolates are equal here among the distributing parties, that means in the groups. So how many equal how many equal divisions are occurring? How many equal divisions are occurring? Equal divisions.
3.
Siddharth, did the recording stop for much of the time?
No. It was actually due to when I pressed the space bar, it accidentally stopped. Sorry.
Okay, no problem. Okay, so see, 6 factorial division divided by 2 factorial into 2 factorial into 2 factorial. But here, one thing to notice is there are 3 equal divisions. So the number of equal divisions is to be divided. So 3 equal divisions means we have to divide by 3 factorial. Now the same thing, I am giving another example. See, if there were 8 chocolates, each to be divided in the way of 2, 2, 2, 2. 2, 2, 2, 2. Okay, let me use another page. 8 chocolates, division by 2, 2, 2, 2, then what should be the way? So there are two ways for you. First one, 8C2 into 6C2 into 4C2 into 2C2 into 2C2. So you can proceed by this way. But there is another way. What is the another way? The another way is to divide 8 factorial by 2 factorial, 2 factorial, 2 factorial, 2 factorial. And we have to divide by another thing. Can anyone tell me what is the another divisor?
4 factorial.
4 factorial. Why 4 factorial? Why 4 factorial?
Because there are four pairs of division which are four division which are occurring here.
4 equal divisions, right?
Yes.
Now take the same thing. There be 8 chocolates. Division is 2, 2, 4 and 4. 2, 2, 4. 2, 2, 4. Right? So now the possible number of combinations is different. In this case, we will divide 8 factorial by 2 factorial, 2 factorial, 4 factorial. What will be the next divisor? Can anyone tell me what will be the next divisor?
2 factorial.
Why 2 factorial?
2 factorial.
There are two number of equal divisions.
2 number of equal divisions, so 2 factorial. Right. So I think you have got what is actually the process of, distribution, not division. So this process is known as distribution. See, basically we are dividing, but if we take in common sense, then we know this by distribution. Distribute these 8 chocolates among 4 friends, right? You have seen this type of problems in class 5 or 6. So this is called the distribution formula of permutations and combination or combinatorics. But there is one division formula. So what is the division formula? So first of all, write the statement for distribution formula. Okay, wait. Write the statement for distribution formula. Statement. If M objects are to be placed are to be divided between n persons receiving T1, T2, T3. So it may seem a bit complex, but remember the way that I told, because I think that is easier. Tk is m factorial by, okay, so many are joining now, m factorial by T1 factorial, T2 factorial, up to Tk factorial into L factorial. So what is L here? L is the number of equal groups, equal divisions. Okay, many are still joining. Wait. Yeah, number of equal division. Now, one thing to be noted. Now you are, suppose here one statement is told among n persons. Among n persons. So what is the meaning of telling here n persons? So there must be a significance. Otherwise, that should not have been given in the statement, right? So in that case, what should we do? We should multiply it by n factorial, right? Is it okay? Any confusion up to this step?
No.
Yeah. Now you may ask, if there are no equal groups, then in that case, what is the value of L factorial? See, no equal groups means L equal to 0. L equal to 0 and 0 factorial is equal to 1. If there is, see, there is nothing like one equal group. So if L equal to 1, this implies 1 factorial equal to 1. There is nothing like one equal group. Can you compare only one object? Can you compare? You can't. But you can compare that there are no equal groups. So in that case, L equal to 0 and 0 factorial is equal to 1. so the division remains same. So that is how. For example, this is a PRMO previous year question. See, the question tells, okay, let me not bounce here. I am giving the exact question. Wait. Yeah, so the question is very simple, but this was actually a 3-marker question. So see, what does the question actually tells? See, the question tells, let n be the number of ways okay, still joining, number of ways of distributing. See the term distributing, here it is told distributing, not division. And this is the distribution statement. See the distribution formula once again, if you have not seen, then only you can do this problem, otherwise you can't. Okay. Now take it. Ways of distributing 8 chocolates of different brands. Again, one thing to notice. No, this is not homework question. This is a PRMO previous year question that we are doing as we have learned about distribution. Brands among 3 children such that each child gets at least 1 chocolate. So there are many points to note. See that words like at least, different brands. Here it is you different brands, distributed. You may underline this. At least 1 chocolate and no two children, again underline, no 2 children gets the same number of chocolates. Same number of chocolate, not the same brand. Same number of chocolates. Find delta n. So what is delta n? So in this case, I may tell you that if you have read number theory, then you know that d of n or delta n actually means the digital sum. The
Sum of digits.
Yes, sum of digits of n or the digital sum of n. So actually, I'll tell you the question here also here. So this is PRMO 2017 question. 3 marks question this was, but very easy. If you know permutations and combination, then you can do it within 30 seconds. Only the question is lengthy. So try it out. I'm giving you exactly 1 minute, 30 seconds for doing this problem. So now it is 10:28 as per my watch. So I will stop at 10:29. Jilok, your answer is absolutely correct. So you have done it within 30 seconds. Okay. Okay, now try it. I'm turning off my video. Sachin, your answer is wrong. Keep on sending your answers. So Eklavya, I don't want the number of ways to do it, but I want actually the digital sum of n. So give me that answer. as it is a PRMO previous year question. Okay, so I am showing the question once again. Eklavya, your answer is wrong, not 18. So this is the question. Legendary, your answer is wrong. Manik, your answer is wrong. Only Trilok has done it right up to this point. Arkaprabha, your answer is wrong. Eklavya, your answer is again wrong. Vanam, your answer is right. So two of you have done it right. So legendary, I want the digital sum, not the answer like that. But the solution you have sent, still I am thinking that is wrong. No, Ekalavya, 108 is not the number of OS. See, basically, see the question that tells you, okay, I am giving you one hint. I will give you 1 extra minute for that. See, so the hint tells you, okay, you can see the recording. See, the hint is actually, see, here the question is telling that at least one chocolate is taken by each child, and no two child takes the same number of chocolates, and the number of the number of children among which it is to be distributed is 3. So the hint is, yes, Trilok, your answer is right. So the hint is actually no children gets the same number of chocolates, but everyone gets at least 1 chocolate. So this is the hint. Arkaprabha, your answer is again wrong. So try to do it now. I am giving 1 extra minute. Maybe this is seeming hard, but once I show the solution, then you will understand it is very easy. Okay, let me start doing the solution. Okay, so one more message. Okay, question. See another. See the question once. Maybe PRMO 5 marker, but as far as I remember, it is PRMO 3 marker. No, legendary, your answer is wrong. Sachin, your answer is wrong. See, actually, this question is asking to make possibilities, that is cases. So how can you make cases? Here one thing is told, I told you to underline that the question tells that no two child gets the equal number of chocolates. No two child gets the equal number of chocolates. Since no two child can get the equal number of chocolate, that means the division cannot be equal. Moreover, the number 8 cannot be divided equally in whole numbers, dividing by 3. So in that case, what should I do? I should find the unequal division possibilities of 8. So there are 2 sets that will tell you the unequal division possibilities of 8. Maybe the first child got 1 chocolate, second child got 3 chocolate, third child got 4 chocolates. And the second set will tell you 1, 3, 4 is done. Then another is 1 chocolate, 2 chocolate, 5 chocolate. Now getting 1, 3, 4, 4, 3, 1, 1, 4, 3, basically same. And also 1, 2, 5, 5, 2, 1, 2, 5, 1, 6 possibilities are same. Since this is a set, closed set. So how can we find the value of n? Very simple. What should we do? Divide 8 factorial by 1 factorial. 3 factorial, 4 factorial, and number of equal groups. Number of equal groups is none. So 0. 0 factorial is nothing but 1. Again, add 8 factorial, second case, divided by 1 factorial, 2 factorial, 5 factorial. So number of equal groups 0, and 0 factorial is 1. So many will do up to this step. One step is still remaining. This is distribution.
3 factorial.
Yeah, right. Multiplication.
Multiplying
Multiplying by 3 factorial. Multiplying by 3 factorial because it tells you about distribution. So it may be called 5 marker, but actually I think it was 3 marker. Okay, no need to argue on that matter. So can anyone tell me what is this result? 8 factorial by 3 factorial, 4 factorial. So I think it is 4 cut and 3 cut. So it will be more or less 280. 280 and 8 factorial by 2 factorial, 5 factorial. That is 8 factorial, 2 factorial, 5 factorial. That is nothing but 168. Right. 168 into 3 factorial, and 280 plus 168 into 3 factorial is nothing but 2688. 2688, and the digital sum of n is nothing but 2 plus 6 plus 8 plus 8, 24. So 24 is the answer. Now see, if you knew permutations and combination, then you don't have to write this step, don't have to write this set format. You have to do only one line. So this may be 3 marker or 5 marker, but actually in reality, if you compare, then it is very easy question, isn't it? So this is actually the level of PRMO. Yes, I agree that there are some hard questions. We will also solve that, but maximum questions are of this type. Mainly of Beggar's method and geometry, grid problem, this comes in PRMO.
How can we solve if?
Yeah, tell.
How can we solve the same question if it is not given that some children will not get same chocolate? Any two children.
Same chocolates are not getting, right? If it is told that every children will get the same chocolate, then you have to do fractions, and the factorial of fractions, I don't know if it is defined or not. Is it defined? Factorial of fractions?
Yes, it is defined.
So what is the value of, for example, say 0.2 factorial? These are super factorials, right? I think I have seen it in some YouTube channel like Black Pen, Red Pen or something like that.
It is defined as the integral, as an integral.
Maybe I don't want to argue it that it's 0.2 factorial is not PRMO 5 marker. It will never come, right? Okay, so the next thing is we will learn division, but before that, very important thing is that say division of division till date, no questions have came in RMO, PRMO. Mainly in JE, questions come from division. PRMO and RMO generally ask for Beggar's method, pigeonhole principle. These are the main objectives of this exam. So we will start learning Beggar's method. Beggar's method. So I think we will cover pigeonhole principle also today. Okay, Beggar's method. So what does actually Beggar's method tell? Suppose there are 3 beggars. This is the first beggar, second beggar. Maybe my drawing is not that good. Okay, so 3 beggars are there, and you have to give everyone at least a rupee. That is, you have to give an amount that is greater than or equal to 0. Greater than or equal to 0. Clear? Okay, wait 1 minute. Somebody came. Yeah, sorry for the inconveniences. Yeah, see, greater than or equal to 0, that means at least 1 rupee you have to give. See, in some footpaths or bridges, you have seen beggars like greater than or equal to 0. No, greater than or equal to 0 only. at least 1 rupee you must give. But suppose you are out with 2 rupees. You saw this beggar, but you didn't. You actually surpassed. You gave nothing. So in that case, you gave 0, but you gave to them 1 and 1. See, first let me complete. You will understand. See, in bridges and footpaths or railways, you have seen some beggars who don't agree even to take 10 rupees. What do? They take the 10 rupees and throw it. Why do they throw it? They ask for minimum of 50 rupees. Have you seen this type of beggars?
No.
Okay, so there are many prevalent here. So yeah, something is there in the chat. Let me see. Yeah, I and see. Yeah. So they don't take small amounts. But if you surpass them, you don't have to give them any amount. So in that case, you give them rupees 0. But if you are giving them, they are such type of beggars who will not take 50 paisa. Who will take 1 rupee minimum. Even you will be surprised to know there are beggars who don't take amount less than 50 rupees. Okay, leave that case now. Now, what actually the formula tells? So write the formula, and I will tell you what is the interpretation of beggar's method. So first of all, write the formula, and I am explaining. So this is the formula for beggar's method. So statement is this, let it be equal to k. Let it be equal to k. K is the number. Okay. So k is the number of integer solutions. Integer solutions to. So it may be heading complex, but I will explain it easily. Don't worry. Equal to 1 to n rk equal to p for all rk greater than or equal to 0. So this is a necessary condition. So in number theory camp also, I taught this beggar's method, because this beggar's method is actually very useful in number theoretic questions also. So see, I am giving one example. You will get clear. So you may have seen questions like find. Okay, so this meeting will end in 10 minutes. You will have to rejoin if you want to come. Find the number. So not in this meeting, I will give another link. Number of, till then try this problem. This may be hard. Number of integral solutions to, what should I give? X plus y plus z. X plus y plus z equal to, let it be 10. For all x, comma y, comma z greater than or equal to 0. So try this problem. Since this is a new concept for many of you, I'm giving you exactly 2 minutes. Okay, 3 minutes I am giving. Try to use this formula. So Manik, you are right. But that can be re-evaluated. So try to evaluate once more. There is a numerical value for it. Okay, try this problem. I am giving you 3 minutes because some of you are new to this concept. But actually, this is 30-second question. Yeah, Manik, you are absolutely right now. Okay, try. Arkaprabha, you are right. Vanam, you are right. Yes, Vanam. The last you wrote, yes, right. The previous one was not right. Sachin, you are wrong. Legendary, you are right. One more minute. So, okay, I think I have given enough time. So, see, how to do this type of problems? Just remember the algorithm. Okay, my video is hazy. Yeah. So, remember the algorithm. X plus y plus z equal to 10. How many variables are here? And remember also it is given x, y, z are greater than or equal to 0. See, this condition is must. Greater than or equal to 0 is must. If it is greater than or equal to 1, then there is another approach. I will tell that. But how many variables are here? First of all, tell it to me. How many variables are here?
Tables.
3 variables. And what is the value of, okay, what is the value of their sum?
10.
10. So, the formula tells you n plus r minus 1, cr minus 1. Here n equal to 10, the value of the summation. And r is number of variables, that is 3. R is number of variables, that is 3. So the number of integral solutions, remember, integral solutions to this is nothing but n plus r minus 1, c. Choose r minus 1. So it is, sorry, not division. It is 10 plus 3, 13, 12. 12C2. So the value of 12C2 is 66. So there are exactly 66 integral solutions. Clear? Of x plus y plus z equal to 10. For all x, y, z greater than or equal to 0, there are exactly 66 solutions. Clear?
Yes.
So try another question. I am giving a similar type of question. Try within, yeah, I will tell greater than or equal to 1. Now try this. X plus y plus z plus v equal to 12. Try this. Exactly 30 seconds I am giving. I want answers from every one of you. Try it. And of course, x, y, z, v greater than or equal to 0. And I will tell what about other greater than, I mean other ranges. I will tell. So Manik, your answer is 15C3. Okay, I don't know what is the answer. So Manik is telling 15C3. Exactly 20 more seconds left. Vanam is telling 455. Okay, so I think the value of 15C3 and 455 is equal, right? So 15 factorial. Legendary is telling 455. Okay. For yeah, 455 is equal to 15C3. Sachin telling 455. Siddharth telling 455. Okay, so majority is telling 455. So let me tell you how to do this. Value of n is nothing but 12. Value of r is nothing but 4. So n plus r minus 1 cr minus 1. And that is nothing but 12 plus 4 is 16 minus 1, 15C3. 15C3 is nothing but 15 factorial by 3 factorial, 12 factorial. And 12 factorial is cut out. And so 15 into 14 into 13, that is nothing but 5 into 4, 14 into 13, that is 455, right? Absolutely correct. 455 is the number of integral solutions for this x plus y plus z plus v equal to 12. Now, okay, let me end this meeting. I am giving another joining link. Join there because this meeting will end in some minutes. So join the second meeting. Thank you.